see you again. It's my personal pleasure to introduce our next speaker, Niklas Muhs. Niklas is a designer focused on creating new ways for people to interact with AI. That's what he's going to talk about later as well. He was the first designer at Mistral AI. Who of you knows what Mistral is? That's quite simple. It's quite famous and leading company and specified in LLMs in France. They are in Europe quite on top. So that's quite cheap. Yeah, and he worked as a first designer. He shaped experiences tailored to consumers, but also to developers and scientists, and very closely collaborating with researchers to explore different AI interactions. Previously, he conducted research at the MIT Media Lab's Neural Interfaces Group, and of course, also in our AI design lab. He bridged AI design in cognitive science. He also worked at Intuity. He designed and developed AI systems for large-scale enterprises, exploring the boundaries of applied AI in industry contexts. And now he's working at Lenovo in Sweden. So join me in greeting Niklas Muhs.
Hello, everyone. So the title of the talk is how we want to interface with AI. And I want to start with a question. So please raise your hand if AI is able to agree with 100% of your work. Okay, 15? 20? Okay. Please raise your hand if AI is able to help you with 100% of your work. 15? 20? 10? Okay, that's interesting. It's about 0. What about 0? Yeah. 1%. But on the other hand, we see statistics like these. Every week when a new model launches, we see these benchmarks where they evaluate these models against different tests. And this, for example, is a math test where they compared the new OpenAI models against the top 0.15% of students in other tests. You can clearly see that the models are very strong enough already. And so I think what I started to think about is where's this gap coming from? That these models seem to be so smart and solving a lot of different problems and benchmarks, but in our day-to-day work, they're not really able to outperform us yet. So I started thinking where this gap is coming from. And some of you may know the German saying, always look for the fault in yourself first. So as a designer, I started thinking, what if it's actually the interface and not the raw intelligence of the model that is preventing us from getting more help in our jobs? So when we look at what benchmark questions look like, they have a few different features. They have a very clearly defined goal that the question is trying to answer. The question always contains all the context that's needed to be able to answer the question. The models get spreadsheets and calculators to be able to work on these problems for a longer time. And there is objective right or wrong in answering these questions. And now what I want to do is a mental exercise where we compare this to the current state of interfaces. So on the top right, we see ChatGPT. And on the bottom left, I will try to outline what I'm thinking while I'm interacting with the interface. So the first time that I open ChatGPT, I basically only see an empty prompt box here at the bottom. And oftentimes I see an arrow on the bottom right that enables me to send prompt. And the first question that I have is, what can I actually do here? So in this prompt box, it says ask anything, but anything is not really helpful. I've never interacted with the technology before. So it basically requires me to know what it's able to do before I interact with it. Now I wrote an example of writing an email. And what I have to do now is basically imagine what the end result is that I want to achieve, and then type into this text box how the AI is supposed to help me get there. And this, I think, is a very complicated mental exercise to think about what we want to have in the end, and then starting to describe it to a different person, or in this case, the LLM. And then what I'm realizing is that in my request, there was context missing. So I have to explain everything to the LLM. In this example was that I know my colleague well, so the tone can be more informal. And I also added the reason for why the meeting was cancelled. So yeah, when we interact with ChatGPT, we always have to add more context so that things are actually relevant for us. And then another thing that's very important is we have to use very clear language that we get understood. And in the next step, when I have the result generated here, I have to read through the entire text and verify that everything is according to my intention, so that the interface basically fetches what I wanted to get. And now when I see a specific thing in here, and I want to change it, I have to describe in words what I want to change. So I can go in and just start typing and what just got generated, but I have to describe it in a conversation setting. And it's not like there's nothing that we can't reference, but yeah, it's just the interface that doesn't let me reference the thing. And all of these are very small details, but added up, they lead to very little understanding of what the interface can do for me. Oftentimes we miss enough context, so the things are not really relevant to what we're trying to do. And there's a lot of friction over time in aligning with the model when we want it to do what we envision. And all of this means a lot of cognitive effort that gets added up. And interestingly, 95% of traffic with the most popular Gen AI tools are chatbots. So 95% of our interaction with language models is in this back and forth setting. And now that I've outlined the problem that I want to talk about, I want to share some interesting patterns that I've encountered during my work that help with alleviating this problem. And what I want to start with is conceptually ranking what the LLMs are actually generating. So this, maybe some of you are already familiar with this. It's a very interesting talk where they talk about how they learned how OpenAI trained their second last language model. Let me see what can we play this.
So the ideal intelligence is called Sokolov induction. Basically, it's uncertain about what universe it's in, and it imagines all possible, considers all possible universes, with simple ones more likely than less simple ones. And it's fully Bayesian. It keeps all of these possibilities in head and updates its views as it progresses. And you can approximate this by finding the shortest program that computes everything you've seen so far. And what we're doing with pre-training, or one way to think about what pre-training is doing, is it is compressing, it's trying to find the shortest program that explains all of the data that humans have produced so far as a way of approximating.
Yes. sorry, this was cut off a bit, but in an abstract sense, these models are very good at simplifying all the data that they see. And since ChatGPT got released, I always thought that this was a huge flaw, because they always tend to generate very generic results, and that this is oftentimes not what we want. But from a different perspective, it can be actually a huge advantage. For example, when I write code and I want to solve a specific problem, there are a million different solutions that I could use to solve the same problem. But the way the model is behaving, it's basically trying to, or it's tending to use the most simple answer for solving the same problem. And for the ones who are familiar with Occam's razor, the principle that when you have multiple solutions, you should always choose the solution that has the least amount of new assumptions built in, because these solutions are easier to test and to scale over time. And the reason why this is interesting for interfaces is that these models always generate generic things that are oftentimes missing context and need to be iterated on. But when we account for this in our interfaces, we can allow the human to iterate on these generic things. And the thought that I find really interesting about this is that if we basically can not repeat anything that another human did before us, we can just think about what is new and build on things that already existed before. One example that I want to share. Sorry. Okay, so this is from my work at Mistral. Now we're getting configured. Oh, the Arkin is getting out. Schlägt immer. Was geht? One, can you hear me better now? Okay. So this was one of the things that I worked on at Mistral. So basically, the state of time was that we only had ChatGPT, and I think the only thing that got integrated by Anthropic was artifacts. I don't know who's familiar with this, but it basically is able to generate or to render code that is generated by the LLM live, so that users can see what the model is creating for code. Yeah. And what we tried to do with Mistral was thinking how we can help humans to improve their writing abilities. I'll just quickly show this right at the end. So what the model does now is grab the code in a canvas, and this looks very similar to maybe code ID. And what it lets me do is go into the code and actually start typing myself. So I can change the code and let it re-render, but I can also go in and highlight specific stuff and ask the model to you can understand me. To style the calculator. And for the ones that are not familiar with the code, what it's doing now, it's basically describing what the different elements in the code should look like. And so the basic or the thing that was new with this kind of interface is that instead of having the static text outputted by the model, we have a workspace that the user and the model can both work in at the same time. And we can basically point at different things that we want to have changed. So now we can see that, yeah, the model was able to help me in style calculating. And now we can think of making changes like making this one button orange, and now the model just goes through. Okay, I thought it would be fast, but now the model just goes through the code and is able to just do the one change that I'm pointing at. And yeah, what was very interesting in doing this project was that we started doing this at the same time as OpenAI. They unfortunately were 1 week ahead from us releasing this. But after we launched the thing, we saw like people use 50% less prompts for achieving the same result, and also had to have like half the time used for making the same results. So this entire thing was way more outcome focused because you don't have the model explanations intermixed with the code, but can work on the actual outcome. Another example I want to show is from Lovable. Nice. So who in here is familiar with vibe coding or Bolt or Lovable? Yeah, a few people. I will quickly explain. So this is basically like ChatGPT on the left side. So I can enter a prompt here, and the model is basically writing all the code that I requested it to write. And then on the right hand side, I can see the code live executed. And it's actually pretty fascinating how non-technical people that have never coded before are suddenly able to build applications where people sign in and pay for different services. Without the person ever being able to code. And something that I found really interesting inside Lovable, so all of this code is generated by an LLM, but we have this one function here that is called edit, and you can now click on specific things inside the interface. And when it's when it's finished loading, I can go into the specific things and change them manually. And this helps users to create these very fast feedback loops where they see what is so now I, as an untechnical user, can just go in and, for example, change the font size, the thing that I just pointed at, and now I'm able to get way quicker visual feedback. Imagine we would have to prompt this every time we want the font to be slightly bigger, smaller. So what I basically want to show with this is that not all iteration is to be model supported, but can also be manually built on top of what the model already generated. So what I want to think about with this plasticity section is that always think of manual first, that the user should be able to do all the things that the LLM is able to do. And that basically nothing that gets generated stays unchanged, but that the human always should be able to change what they see. And then create these spaces where we have very fast iterations, where we can get a quick visual feedback for what we're changing. The next thing that I want to talk about is context. And here I'm referring to both creation and curation of context. You can show one example. So this is from Apple Mail. And what they introduced last year was what is it called? Writing tools. And usually I would see this directly when I want to reply to an email, but these are different options that I can use to edit text that I'm referencing. And what I find really interesting, so I'm talking about the wrong example, sorry. Let me jump to another thing. So what I wanted to talk about was adding context and curated context. And in this example from Claude, so they have different ways of adding, for example, files into the chat. So you can add more of the relevant stuff that you want to talk about. But what I also find very interesting is thinking of bringing Claude to the contexts that we are already working in. So, for example, with Visual Studio Code and Ko-Fi, we can see that LLMs are able to help programmers way better in their own spaces, like compared to coding tools like Lablook. And another thing that I found very interesting of what Claude is doing is they have these different things inside the chat conversation, which feel very like an artifact or like a document that you can refer to. And these, I think, help users a lot to mentally wrap their head around what they're generating in these conversations. Because over time, yeah, when these texts get very long, can get very easy to not understand extremely. And the other example is targeted contexts for the person, but they enable users to basically curate the things that are referred to in the requests. So, for example, here, it's very small. I can add docs for different frameworks that I, for example, want to reference in my request. So these kind of things help me, create things that are contextually more relevant for what I want to generate. The next thing, the modes. Now we'll come back to the example from Dublin with the mails. So they have introduced these writing tools. And what I find really interesting about those is that Apple thought about what are the most common use cases that users use AI for. And then we just create one button that always does the same. So basically all these frankly professional concise things. So when I maybe because I turned off my VPN. But usually, or what we can think of them is that these things are very repeatable and always have the exact same behavior. And what I find interesting about this is that Apple faces a very different target group than ChatGPT, for example, because they have to think about very non-technical users that sometimes see AI for the first time in their own interfaces, for example, on the Mac. And then these features, these very complex features become way more understandable. And also from a technical perspective, I think this is very relevant in the future because what Apple is doing in the background is they're using very small models that are fine-tuned to always perform this one action. And this allows these things to run on your MacBook, not in the cloud somewhere on servers in the US. And so there will be way more smaller specific models that have very predictive behavior. This Apple showed. And the next thing that I want to talk about is affordances. I think this is the most exciting part because it really, or what I'm thinking of here are proactive affordances, where the model already thinks about what the user might want to do next. and these things weren't possible before. Something that is very interesting to look at is how these models are supposed or used to work. So in model training, there are different phases. And in the first training phase, these models get trained on predicting next words in a line. And only after that, we train them to have this dialogue that we're having in ChatGPT, where they are able to answer specific questions. And so, for example, in this request here, I'm basically prompting the model this guy is. And what it's doing then is completing the sentence with the limit. And then, interestingly, it writes again, this guy is the. But what I think is interesting is that the model is basically completing what I was thinking of before. And with coding environments like these, the models. So, okay, so I'm doing something in my coding environment, so I'm starting to write something. And because the model is trained on predicting what is likely to come next, they can show me different things that would be relevant in this case. And what is really interesting from an interaction standpoint is that now I, as a user, only have to look at the final result and decide for myself whether this is relevant or not. And now I only have this yes or no decision. And if it's no, I can start typing and do something else. And then basically see how the model adapts and helps me further make this more precise. And I think this is very interesting because we're now not thinking of having this dialogue about our work where I have to describe to someone else what I want the other instance to do for me. But now I just do my work and have someone that is basically predicting what I'm doing next and offering me these kinds of things. And I think the only thing that's holding us back from doing more of these is the speed of the models. Because we, of course, don't want to wait for a minute until the model generates everything and then offers us to autocomplete. But something that is very promising, I think, is that these models got 10x more efficient for the past 2 years. Then this versus this trend, then maybe in a few years, we will only see auto-completions and in our working environments. We don't have to have this meta conversation about what we're trying to do. But of course, this is not always feasible at the moment. And one demo that I also want to show. So in this case, I was trying to think about how the model could align with us or propose something without generating the entire thing. And what I can do now is basically let the model interpret what I could have meant with my request. So, and now, so what the model is writing up here is basically all the things that I could have meant with my request down here. And now, as a user, I can just go in and click the things that are relevant to what I actually want to achieve. And the AI is just able to pick them up and refine the prompt. And this way, I don't have to think about what are all the things that I need to specify in my prompt. So the AI is understanding me, but I can just look at different things and choose whether they're relevant. Something similar that we're doing then inside Laravel is after each request, we basically always propose different things that would be relevant to users. So they can, after they get a response, they can just click on things and don't have to think about prompting them. And what we saw is that this makes users way more successful because oftentimes you know what they need to do next to be successful before they know. Because we see all these repeated behaviors from a lot of users. Yeah. So now we have these 4 different concepts that we just talked about, and I thought a lot about these patterns. And when you basically swap the direction of them, ironically, they correlate with something that replaced command line interfaces back in the 70s. So maybe some of you are familiar with the WIMP model, the windows, icons, menus, and pointers. So these were the things that basically replaced the computer interaction where we had to type in one line and know all commands by heart. Yeah, and so the windows in this WIMP analogy are basically helping us to manage contexts when we are interacting with the AI. The icons are affordances that sometimes you can predict what we're trying to do next. The menus expose controllable behavior, like in the example where I can choose from different features. And the pointer is like in the canvas example, where we can reference specific things and start editing manually. And my hope is that at some point the interaction with AI goes to the same richness like we have in our brain operating systems. Maybe you can go beyond. This is the part of another video that I wanted to show. This is from the 70s, from Alan Kay and his team at Xerox PARC, where they developed Smalltalk. So this, I think this video is 7 years old, but they're trying to show what this system did back then.
By one, and this little operation is pronounced make a point, 1. So that makes an XY coordinate there, that's an offset. And we'll tell that to come. Okay, and now I'll recompile this. So we're down in the deepest part of the system here, definitely recompilation. But recompilations are always fast in a message-oriented system because there's no need to relink everything. Messages do that automatically. And now I make this selection, and we'll look at that. And amazingly, it actually extends to another area. It might be nicer really to have that offset be 2, just to show how, development goes so fast when everything just responds immediately. We often said that the Smalltalk systems ran at about 1/4 the speed of other systems that our competing labs were building, but the turnaround time for change was like 1/10 or less.
Yeah, so what I found really interesting about this example is that with Smalltalk, they created a system that is meta-circular. And that means that all the components the system is composed of are written in its own language. And what it enabled the engineer Dan Ingels to do here was to edit the system while it was running in its own language. And there's one very interesting story from when they showed this graphical user interface to Steve Jobs for the first time at Xerox PARC. And they demonstrated the system and was scrolling text line by text line when they were scrolling with the mouse. And Steve Jobs said that he wanted to have smooth pixel line by pixel line scrolling. And the same engineer from the video, he was able to edit the system on the spot in under a minute and show to Steve Jobs that they didn't need a reboot to edit the system. Somehow Steve Jobs only took the graphic user interface part, not the editing the system while it's running. And today, personal computing has this huge division between users and designers and developers on the other side. So these huge feedback loops where we split between experiencing our own tools and shaping our own tools. And well, what I'm really excited about with tools like Laravel is that we have 80% of users that are non-technical, so they didn't code before, and suddenly they're able to and create their own tools or change them over time. And I think that's a very promising future when these AI tools integrated in the proper way allow us to do new things with our computers. And something that I also found interesting is with Apple, when Apple was introduced the Macintosh, they called it the computer for the rest of us. Now with Apple Intelligence, they're trying to promise to do something similar, so AI for the rest of us. But maybe they're right in that this will lead to a revolution for personal computing. Yes, thank you.
Lunch. We don't have too much time left, but there's any questions?
Yeah, for the applied there, one last question out of curiosity. You don't have to spill your own secrets, but there was one part of the interface that was you did not mention in the talk, is just language as an interface itself, which is probably the revolution right now. So just the language used. And I was wondering who in the companies work with or in the processes, who designs the language? Like, for example, there is no person who decides and says, I thank you and all the stuff. Is that part of the design process? Is that part of the engineers? Or is it just now the standard that they say, I thank you and all the stuff? Because arguably that's also interface design, in this case, designing the language used. Yeah, I was wondering who in the company of Anthropic decides this language part.
Yeah. I think that's a very interesting question, also very relevant for design. So I cannot talk about Mistral specifically. So I'm trying to summarize what I see over the different research companies. So there are these new job titles emerging that are called model behavior or behavioral product managers. And so in these training processes, what I talked about before is its first stage of pre-training, and then sometimes mid-training and then post-training. And during post-training, you basically tell the model how it should behave or answer questions. And this is where those model behavior people basically decide how the model should behave. And this is very relevant for safety. And also, yeah, what the overall user experience is going to look like. And I think what is an interesting trend that I'm seeing is that writing these e-guides or specifying how the model should behave is becoming a new job. And that is something that developers don't want to do. And maybe designers or product managers are more relevant for this. Yeah. Does it answer the question? Yeah. Yes.
Another question.
Oh.
Right. Maybe one last I can ask a question.
Yeah.
And what I thought about is if you're thinking of the future of interactive AI, do you think it would be like one new paradigm, or would it be like many different options of interfacing with AI? And if you are at work, is it always one goal that you're trying to achieve in different companies? Or are there different, very specific goals for very specific applications?
That's very interesting. I think, or it always depends on the user. I think with these AI tools, we're coming from very different directions, or from the same directions, to different people in the end. So the customer at Mistral is very different from their customer at Lovable, because they're trying to achieve different things. And same thing, for example, when we compare Lovable with Cursor, we have two types of people that want to code in app, but they have very different pre-knowledge from working with these tools, and the interfaces look completely different for a reason. And so I think it's getting richer, the space of interactions that we're representing, instead of this one notification.
Very interesting. All right, then. Oh, okay. Last one.
First of all, thank you for the talk. I really found it interesting to see because we're always working with these tools, and now I'm gonna have I don't know, like a view behind the scenes sort of thing. So my question might be a little bit specific, because the talk before the talk before we had the number of the energy consumption on prompt, for example, or the how a smartphone charge or image generation. How would that transform into the new ways of interacting with the tools? For example, the auto coding interaction that you mentioned. How's that? How much energy does that use from, for example, if you compare it to giving in a prompt or giving an input prompt and then pressing enter, and now it's all doing it by itself? Is it always going through the loop of regenerating, or is there actually energy efficiency that is reached?
I think that's a very interesting question. I don't know the specific numbers, what it takes to autocomplete compared to instruct. I guess my guess would be that instruct is more intentional, so it's maybe less energy intensive. But what I think about generations in general is maybe very opposite to what you talked about before. But that when we think about, or let me try this, doing this open spot. Did you talk about how much energy one token consumes?
Yeah, right. So.
Yeah, and what I did a while ago was one calculation where you basically multiply all the tokens and divide them by 2000 kilocalories, what the average consumption of a human is. And you basically can equate the daily human energy consumption to 8 million tokens. And it's a very unfair comparison, I think. But when we think of 8 million tokens, that's 6 million words written per day. And that's what no human is able to do. And when we think that we invest some tiny amount of energy into making the human more capable in, for example, coding, the energy invest maybe have a much higher return than when we would put more humans in front of the computers. And that's why it's a very unfair comparison, I think. But I think it puts a bit into perspective how much energy we humans maybe take for doing the same amount of work. That makes sense.
Yeah.
All right, very interesting. So thank you again, Niklas. And now we have a small break. You can now play.